So the highlights of this demo is this. The set of highlights is that we're actually making a call to this method inside of our class, which obviously becomes available once we have an actual object. We named it calculator. It was created by the new operator, and we specified what the type is and did all this. So let's take a look at what getSquare does. So gets invoked, receives a parameter named value over here. So the value 3, see I'm passing a hard-coded value of 3. This value of 3 gets passed to the method, and this value becomes 3 by the time we make this call. And the execution control reaches this method. And the next line executes. And of course value is 3. So we immediately call calculate square. And this calculate square is another method. But it's declared private. That means that in this demonstration, the intent is to make calculate square part of the class implementation. It is not intended to disclose calculate square to the user. The user is not supposed to call this method. Instead, we can call this method whenever we feel like part of our object implementation. And of course, because this is also private, the value that is being retained inside the this particular class, this is also part of our class implementation. So part of our interface is only this single public method, getSquare. What happens is that once calculate square does its work, 3 times 3 right here gets computed and returned from this method, the value is returned, stored in our private attribute in memory, because our object now allocates spot in memory, which is expected, and of course it explains what the state of the object is. To keep track of time. And then we return this result, this computed value, back to the caller. Then we come back to our main method. The result now is in our local variable named result. So again, what we could try also is that how about we say result equals calculator dot, and we can say calculate square, which also takes value as an input parameter, right? So NetBeans code editor already checks the syntax and checks the basic settings in our project and already knows that something is wrong. But if I do go back to the project view, and as you know, I have this option to clean and build, I'm expecting it to fail, and it fails by saying error calculate has private access in square. And that's the line which is trying to offend the rules of encapsulation and obviously makes everybody unhappy. So cannot do this because this method is private. So I really need to find a public method which will be suitable for what I need to do with my object. Okay, so small demonstration like this. Any questions? Right, let me just shut down what I don't need. And going back to the slide, we also, where am I? We also said that for every class that we design, here we sort of like went backwards because we already looked at the source code. We said, okay, why don't we try to use the source code, see if we can create an object, see if we can do something, in demonstration. But here's the corresponding UML diagram. So UML diagram has the name of the class. It's a mandatory part. Has an optional set of data attributes. In our case, minus in front of it, in front of square value, indicates that the the attribute is private. And then we have get square, which is our public method. It returns an integer. And then we also have a private method named calculate square. So kind of, overinflated little demo thing. Let's move on. We also would like to introduce today, it's really packed with features presentation today. We also would like to let you know that there is this new design idea that is possible and supported by object-oriented environment, and that is inheritance. Inheritance is a relationship, a set of definitions towards the relationships between our classes. So here's an example from the textbook. There's a mammal, and there's a dog, and there's a cat. So there's lots of commonality between dog and cat. There are lots of things that are different, right? I could extend this. So let me also bring up our paint. I guess I can experiment with some of my painting skills. So if I say this copy image, and I should be able to paste it in, right? And if I take like pencil, I could also say, oh, by the way, I could also have something, and this is like square, triangle, or hollow triangle, and say, I could also think about something called, smart cat, right? Smart cat, and that's the analogy with smart TV, I suppose, right? So a smart cat could, maybe knows really well how to hide, right? Or how to hide its feelings or something else, right? So making a smart cat is that a demonstration that we can think of a mammal class, and we should be able to explain to the world why we think it's useful to have this class. Well, in my view, why replicate eye color in a dog and a cat if we could just have a common piece called mammal, and it will include the eye color. And then of course there's a getter and maybe a setter method here that we could add instantly, which will work exactly the same for a dog or a cat, right? And then it also will work the same way for a smart cat, because eye color and get eye color and set eye color will also work well. So right now I'm not talking about any technical details about this. Is just an idea that, look, if you think about the smart cat, right, it has a piece which is common for any cat, and there's also common piece for any mammal, right? And so there's another subdivision of this which applies to dogs, and we could probably come up with a smart dog as well, right? Or dumb dog. Now, check the time on this. Okay. So right now, not talking about anything technical, just the design idea that, look, instead of just talking about cats and separately about dogs, we can actually bring them into the same picture and say, oh, they have a lot in common between themselves. Very interesting. And in software, you should, especially when you work on non-trivial project, you write a lot of code. As soon as you sense that you keep writing the same thing over and over and over again, it could be somewhat similar circumstances, but you're sensing that you're actually repeating yourself. It means that you have some common piece in your software, and you should immediately alert yourself and say, wait a minute, I should probably have one single method or one single class that does this, and everywhere else where I need to use it, it should be done in such a way that I'm just making a method call instead of copying and pasting like 15 lines of code and tweaking them somewhat. Instead of tweaking, maybe your method should take a sufficient number of input parameters which can control how things are done internally. Okay, so it's not necessarily related to classes, but it also relates, the idea of seeking commonality applies to your regular code, just every single line of code that you write, right? If you repeat the same thing over and over and over again, it should probably be a unique method and not copy and paste of the same thing in multiple places. Okay, so this is almost like one of the most fundamental principles. You should, as a professional programmer or professional designer, or professional project manager, whoever, whatever, or maybe even an expert user of some software, you should sense that commonalities exist, and you need to be able to describe them, understand them, and isolate them. And it's just like every time you sense something like this and you detect it, it's a successful day, okay, for you as a programmer. All right. So we're going to be talking about classification, which is sort of like, okay, we do deal with classes. It's basically splitting your software into multiple classes, but also generalization, which is, by the way, a UML expression of commonality between classes. So all of this to be explained, right? So let's talk about this.